And go. Okay, good morning, class. Today we're going to be doing similarity. Why did I capitalize this L? I don't know. Okay, I'm a math guy, you know, and it has to do with proportions. All right. So the idea behind proportions is as follows. The best analogy I can use to teach it, real quick, is this idea. Like, have you ever had a picture that you've put on, I don't know, Word or maybe some sort of picture application like Photoshop, and here's a picture of a guy. Hello. Right? And then you have this little thing here, and you can drag it and you can make it bigger and smaller, right?
Yeah.
Sometimes when you're dragging it, making it bigger and smaller, it's locked in terms of its proportions, meaning sometimes you can do it like so that's like this. It's like, ooh, I made him on a diet. Yay. You know, like that. So sometimes it's like that where you can smush it, and sometimes it's when you can widen it, you know. But sometimes you can't, and it has to stay proportional. Do you understand what I mean? Any questions about that? That's the idea behind similar shapes. So like you can stretch it, but it would also be something like this. And it would look the same. Granted, maybe a little faded because you're stretching it out, but it looks pretty much the same in terms of proportions. And that's the idea behind similar shapes. They're proportional. Okay, so if I wanted to do, let's do a shape here. Triangle, this one, and all right, and let's do 3 and 4. Okay. Now assume triangle A is similar to triangle B. Okay? The symbol for similar goes like this. Triangle A, similar to triangle B. Okay? So it's kind of like that congruent symbol without the equals underneath. All right. So what is the relationship of triangle A to triangle B? Meaning, if we were to compare one side to its corresponding side in triangle B, the ratio would be what to what? Number-wise. Yeah?
3 to 4.
3 to 4, right. So this is 3 to 4. This relationship, I want you to know the word, or the vocab term for it. This relationship here is called the scale factor. Scale factor, more or less, is the relationship of one side to the corresponding side in a similar shape. Okay? So for every 3 that's on this, you'll have 4 here. Okay? Now let's get into it. Let's say I wanted to solve for x here.
Isn't this like we did yesterday with the cross multiplying?
Yes, we will. Exactly. It builds on that. It's like what we did yesterday. So let's say this. 16. Okay. Now we need to set up a relationship. We need to set up a proportion to solve for x. Okay? Can anyone set up, as I erase Uncle Joe, can anyone set up a proportion in the back? Yes. Go ahead.
3 over 4 equals x over 16.
Good. 3 over 4 equals x over 16. Before we solve, can anyone set up another proportion that would work? Yes?
4 over 3 equals 16 over x.
Good. 4 over 3, 16 over x. And now we're going to go over here. If you are to miss something, if you were to get something wrong, it would be as follows from years past in teaching this. 4 over 3, in other words, left over left equals bottom over bottom. There is a sort of rhythm to it, right? You could even say left big over left small, bottom big over bottom small. Tell me if this would be wrong. 4 over 3 equals x over 16.
Yeah.
Wrong. That's wrong. That's wrong. Any questions about why that's wrong? Feel free if you're thinking it's someone else's. Okay. So that's good. We have 3 over 4, x over 16. 4 over 3, 16 over x. What's another one that might work? Rhythm-wise. Yes?
3 over x is the same as 4 over 16.
Right, I heard 3 over x equals 4 over 16. That's good. You can say left over bottom, left over bottom. And as well.
So then could you do 3 over 16, 4 over x?
No, that's right. That's a good question. 3 over 16, there is no relationship with 3 and 16. All right? And besides that, 3 over 16, this is a lot smaller than this is big. And this one would be bigger than this. So there's no relationship, right? So I heard 4 work. This over this over that, that's 1. Back the other way. And 3 over x, 4 over 16. Okay, that's the idea. You'll know what I mean soon. So let's go ahead and solve. We can cross multiply, or we can do other things algebraically. See relationship here? How do you go from 4 to 16? Times 4. So 3 times is 12. Okay? All right. Now, let's get into another one. All right. We're actually almost done, believe it or not. Let's do the 4, 2, 6, 5, do 5, and x, 10, and y. Okay. Welcome to the land of SAT, where they mess with you, you know, and I hate that. But let's mess with them back.
I have a question.
Yes, please.
What type of triangle is this that you choose? Is that an isosceles or what?
It's not given.
Not given.
Yeah, it's not necessary. It's irrelevant in a way, whether it's isosceles or not. All we're focusing on whether or not they're similar. Okay? Whether or not they're similar. So right now, how many triangles do you see here? Yes? 2 triangles. That's right. And let's assume it's given that the 2 triangles are similar. All right, the 2 triangles, if you don't see them, is the small one here on top, and then his friend there. Okay? So in the spirit of them messing with us, we're going to mess with him back. You know, when I was growing up, when I was your age, I had a lot of bully trouble. Like I wasn't as this tall always, and I was bullied a lot, believe it or not, because I was shy and stuff. And my dad was like, if someone hits you, you hit them twice and twice as hard. Always stuck with me, you know. But it didn't always work. I just got hit. Okay, so who can look at this and let's say do a relationship to solve for x? Yeah.
10 over y.
10 over y.
And 5 over 5x.
Okay, so you made a relationship with y and x in the same equation.
Oh, okay.
You did 10 over y, and then 5 over this. And so it's 2 variables, right? So try again.
Then 4 over 6 and 5 over 5.
All right, he sees 4 over 6. He sees 4 over 6. Where is 6?
To get the whole triangle, it's 4 plus 2.
Right, right. 4 over 6 is a good find, okay? You wouldn't always see that right away because you're comparing the 2 triangles, aren't you? 4 over 6. First and foremost, can you give me the scale factor of the 2 triangles? Scale factor of big to small? Yes? Or excuse me, small to big. Go ahead.
It would be a 4 to 6.
Okay. 4 to 6. If that's not simplified, so it would really be 2 over 3, or 2 to 3.
I'm not getting it.
Okay, I'm glad. Let's simplify this triangle in the sense that if there are 2 triangles to compare, let's draw them. Okay? So now here they come. All right. Cornelius. What are the dimensions of this triangle starting with this? Left side? What's this one?
Relative to that one?
Yeah. This one.
Oh, so 3, right?
No. I made it a little smaller. Yeah. 4, bottom,
10,
10,
5.
5. Okay, so that's 1, bring this one over. Okay, voluntation to do this triangulation. Yeah?
6.
So we're
Six.
seeing 6, right?
5x on the other side.
Okay, 5x. Many people say 5x.
5 plus x.
You're not the first, you won't be the last. This is 5 plus x. Okay.
And y at the bottom.
You can just answer the question, you don't have to ask why. So what's the bottom?
Y.
Dude.
Okay, z.
Yeah. I wonder if I will never stop saying dude for the rest of my life. You know, it's kind of a kid word. I'll be like, dude, do you want some dollars from grandpa? But then it'll be like, dude, do you want $500 to buy a candy? Dude! You know, on the phone with the bill collector. Dude! The bill was wrong this month, dude. It's like, aren't you old? You're not allowed to say that anymore. Like, dude, OMG! Alright. Now, let's make a relationship with X. Much easier. You want to try it, Ulysses S. Grant? Okay.
6.
4 over 6, you're right. Equals.
10 over y, right?
Okay, cool. You're solving for y. Fine with me.
Oh, you want x.
Doesn't
5.
Yeah.
5 over 5, right?
5 over 5x. 5 plus 5 over 5
Yeah,
plus x.
5 over 5.
Okay, great. Now let's go ahead and solve this. All right, so we can take this one off, the confusing one. We hit the confusing one twice and twice as hard, so it's gone. And now cross multiply. Can we simplify 4 over 6 first? Good habits.
Yes.
Algebra becomes
2 over 3.
2 over 3. It's cool. It's like you're talking right into the mic. 2 over 3, baby. 2 over 3.
Could you do it on the other side too? Make it 1 over 1
No,
plus x?
right. You can't do that because 5 would have to go into both. Okay? 5 plus x is its own entity. So it's either all or none. So this is 2 over 3.
Does x equal 2.5?
I don't know. Let's find. Isn't that the fun part? We discovered together. We discovered together. This is the symbol for discovering together. Like mixing dough or something. I don't mix dough this way. Never mind. 2 times 5 plus x equals 3 times 5 is 15. All right, I can just go through, right? 2x equals 15. Yeah.
It's 1.5. Oh no, 2.5.
Yeah, let's stick to the land of fractions, where everyone's equal. X equals 5 over 2. Okay, so we got our x. And then I heard, yeah, for y, anyone? Everyone, 4 over 6 equals?
10 over y.
10 over y. Very good, everyone. 4 over 6 equals 10 over y. Okay, and then we can solve for that. All right, questions on the idea of making two shapes and making comparisons. Again, we could have done 4 over 10 equals, for y. 4 over 10 equals?
6 over y.
6 over y. Questions on that? We could have done 4 over 5 equals, for x?
6 over 5 plus x.
x. Very good. All right, a few more things. Are the sides the same in similar shapes?
No.
No, they're not. The sides are not the same in similar shapes. They actually can be. Even if you have shapes that are the same, they still are proportional. Okay, so the sides aren't the same. What about the angles?
Yes.
You think the angles are the same?
Yes.
Let's do it, right? If we had this original shape here, this marker's about to die. Come on out.
Resuscitate it.
Are you seeing
Oh, it works.
Yeah.
Really worked. Okay, look. If these two shapes are similar, yes, these two angles are the same. Right? This angle is the same as this. These two are going to be parallel. Thus, these two are, what's the word for this? Starts with the C, these two angles?
Corresponding.
Corresponding. You're learning. So happy.
You know you're not in the,
What?
you're not in the camera.
I'm not in the camera.
No, you are.
Fake cry now. And now these two are the same. All right. So similar shapes have equal angles. That's right. And then finally, there's one more thing to learn. There's one more thing. All right. So the scale factor of a shape is comparing one side to the other side. All right. Now, if you compare areas, have you ever talked about the area in terms of like square footage of a home? Right? In terms of area. The area is an idea of squared space. Squared space. Okay? So if we were to compare the areas of two triangles that have a scale factor of 2 to 3, their areas would be 2 over 3 squared. So the area of one triangle would be 4, and the area of his friend would be 9. So the areas would be 4 to 9. Okay?
I'm confused.
I'll give you an example. All right, quick example, because it's a legitimate confusion. You have to see it. Let's do. Okay, let's do rectangles. All right, similar rectangles, let's say would be 2 and 4, and then 3 and 6, right? So these two rectangles are similar, correct? See how they're similar? 2 over 3 equals 4 over 6. Okay. What is the scale factor of rectangle 1 to rectangle 2? Yes?
2 over 3.
2 over 3, or 2 to 3 we can say. Usually that's how scale factor goes. Okay? So that's the scale factor. What is the scale factor of the areas? So what's the area of this? 8. What's the area of this?
18.
18.
You just sounded a little
Okay.
wrong.
What?
You just sound, enough.
18. All right, so do you agree that this area is 8 over 18? Okay, and what is 8 over 18 simplified to? 4 over 9, doesn't it?
Which is 2.
4 over 9, which is 2 over 3 squared. Okay? It's 2 over 3 squared, excuse me? You got it? 2 over 3 squared.
Yeah.
2 over 3 squared. No, sorry. Okay, so that's how area works for scale factor. Okay? And then, let's say we have volume. Right? Last bit.
Keep volume.
Volume loves you.
No, it doesn't.
True. Yeah. Okay. Okay, so we have volume, and let's make it easy. Let's make it 2 to 3, 4 to whatever. What about 2 to 3? So what would it be? Let's double it again. What's 2/3 of something? So. Okay, I don't need the numbers actually, because if we do the numbers, it's just going to get out of hand. I want to do conceptual. Okay.
I don't think the volume likes you that much.
Volume likes me too, because I know how to handle volume. Yeah, there, volume. There. Okay. So do you think if the scale factor is 2 to 3, the area is 2 over 3 squared, the volume would be 2 over 3 cubed. That's how volume works. You know how area is side times side? All right, so that's your square component. And then volume would be this. Okay? Yes?
Would you want us to solve it or just leave it like that?
No, solve it for sure.
Okay.
Yeah, 4 over 9 is right. And so the volume scale factor would be 8 over 27. So this volume's scale factor would be 8, so this one 27. Okay? Summing up, scale factor is side to side. Scale factor of area is side to side squared. Scale factor of volume is side to side cubed. Okay? How long is that?
19 minutes and 30 seconds.
19? Okay, good. We're under 20. Awesome. Thank you, everyone. Give yourselves a hand. We're going to camp now. Who wants a cookie?
I do.
All right. Here we go. Oh my God, you're actually going to take it. You want a cookie?
Yeah, here, throw it.
Will you share?
Here, I'll split mine. 80.
Not a good
You
answer.
say yes and then.
Yes, yeah, okay, I'll share, I'll share.
Okay, yeah, I'm not gonna share.
That's got. Oh, nice.
Nice, that's how you do it.
Here, who wants
What happened then? Oh, the cookie was chopped.
More to come.
5 seconds.
Like that does anything. Like, I'm actually gonna do it. It's like try on it. Salty.
You eat it?
I actually didn't do anything. I just went like this, guys. Okay, bye. You can hit it off.